Thank you for coming to the DevOps track. I'm Josh Corman. I put together a track of 5 different talks today, so you can come to them a la carte, but I wanted to at least frame that if you intend to see the track as it was intended, a very quick overview of who we picked and why we picked them. So we're going to kick off the day with one of the luminaries and pillars of the DevOps community. He's also behind DevOps Days, and that is John Willis, who at the time was at a different company, but now I must point out that he's at Pacific Crest Securities, but he is one of the central thinkers, philosophers, promoters of the positive patterns of DevOps. And what we really wanted to do is for a lot of security people who are either afraid of DevOps or reluctantly embracing DevOps to hear it from the horse's mouth. So this is really DevOps proper, where it came from, what the value is intended to be, fairly independent of security. Following John, we have David Mortman, who's a security guy and thinker, but also a DevOps and automation speaker and writer, and I hate to say thought leader, but I'm going to say it. So that's going to be a really nice way to transition between, so what does DevOps really mean for security people? Not the FUD, not the sunshine, rainbows, and unicorn poop, but what it really means. And that's a really good introduction if it's new to you. The third talk we have is Damon Edwards, who's really helped a lot of people get started on their DevOps journey. And that's going to be like, if you're just getting started, what does it look like? And how do people tend to get started, and where do they go from there? And then if you're really good at this, we asked Chris Swan to come in because he's doing some advanced stuff, like how do you make products based on DevOps toolkits and tool chains like Docker. And that's both going to show the glory and the horror of what it means to security. In some ways, it makes it much, much worse. In other ways, it makes it much, much better. But the reality is people are adopting these technologies and these philosophies, so we have to embrace them. And then to close out the day, we really wanted a practitioner's eye view. So we have Matt Tesaro from Rackspace, who's fully embraced this and had his lessons learned and his bruises and scars, and that should help you round out a real practitioner perspective on all that. So again, DevOps Foundation, DevOps myths and facts and fiction for security, getting started with DevOps, getting advanced with DevOps, and then a practitioner's full embrace and case study of DevOps. So we really hope that you enjoy the day, and without further ado, I'll give the mic to John.
Great, thanks Josh. Hey, thank you everybody. It's funny, I'm not a security guy, right? So I do a lot of these presentations these days. I spent a lot of time in the network space over the last year in DevOps and networking. And I have to start up with I'm not a network guy. So, and then somewhere along the way they get that I kind of understand the space. But I've been kind of reluctant to be a security guy because there's just so much. I know David, me and David worked together, and I know Chris Hoff a little bit. And I realize, there's something special there that I have to learn a lot about before I should even get up and try to talk about things. But the thing was, in the keynote this morning, it was interesting how relevant a lot of that discussion this morning is so in line with the things that Damon, this is another good buddy of mine, we've been talking about. We do a DevOps Cafe podcast together. And as he was going through some things I didn't agree with him, but for the most part, it was interesting how relevant mine and Damon's story is to what's going on here, even though I thought it wasn't. That's my start off. So I'm John Willis. I'm Botchagloop on Twitter. I'm currently an executive in residency, which actually just means the world is tilted off its axis. The fact that I would have a title that has the word executive in it, and working for an investment bank, but it's really more of an entrepreneurial holding ground for kind of startups for another thing. So think about an EIR for a VC, very similar to that. So quickly, I'm going to go through the introduction. Kind of the agenda here is I'm going to do kind of a little introduction, tell you about what I've done and why I was invited here. And then I'm going to do a quick DevOps overview. I call it the who's to blame. So a little bit, I'm not going to tell you much about DevOps. In fact, I'm going to show you one slide and I'm going to say that's the best definition of DevOps. But I'm going to then talk about who's to blame and then go through like what did we get to where people are now, every conference now has a DevOps track, so. And then I'm going to talk about kind of like what I think is relevant of what I've been talking about, which is kind of software-defined everything. So to me, at this point, if you buy into what I'm saying about DevOps and you think it's a nice pattern to doing things for security, for software, for network, for whatever, then I would say that the next place that we go is kind of a software-defined everything, and the underpinning that would be the DevOps of everything. Make sense? And you can smile, you can laugh. I might cuss, just getting you I don't know if this is a cussing conference or not. All right, here we go. We got one. All right. So here's the thing about DevOps. We could spend the next 4 days, week, arguing about like DevOps is this, and if you remember that term cloud, right? We had the same argument about that, right? And I'll tell you right now. I mean, I think you're going to get a really good explanation from David, and then Damon. I really encourage you to stay around for those two, and probably the whole day. But I think you'll get a lot more to see the view from a practitioner, especially from David, who I really think has really led the DevOps security, in my opinion, story. And then Damon, has a really good story to tell as well. But so all I'm going to say really about DevOps is what Adam Jacobs says. This is the fallback position, which is it's a cultural and professional movement, full stop. I lied. I'll say one more thing. It's a metaphor, right? Like, in other words, what we started out with, DevOps. There was a wall between Dev and Ops. And we really just wanted to solve that. And then people say, well, should we call it Sec DevOps? Should we call it Sec this? It's a metaphor. There's a broken communication between two groups. In the keynote this morning, it was clearly security and developers, right? The people who started this thing were really concerned about data center infrastructure and how bad the relationship was glaring above all, in our eyes, between developers and operations. The wall, right? So it's like, how do we collaborate? How do we break that wall? So I think a better way to kind of follow through is, how do we get here? Or if you hate DevOps, these are the people you can go beat up. Okay? All right? So don't beat me up now. Okay. So I'll start with the more recent, which is Patrick DeBar. So Patrick DeBar was in Belgium. He basically, as a software developer that was kind of straddling this problem of being a smaller infrastructure where you don't have large ops and you don't have large dev. And he went around starting asking, hey, is anybody trying to solve this problem of agile and operations? And there was a great discussion going on about agile operations, agile infrastructure. And actually, in the 2008 Agile conference, Patrick went ahead and put out a BOF request to see if anybody wanted to talk about agile operations. And I saw Damon get pissed. I think that's one of his slides. No, all right. And so nobody came. There was one guy, Andrew Schaefer, who's a good friend of mine. He was one of the founders of Puppet Labs, and like nobody showed up. I don't remember if Andrew did the BOF and Patrick showed up, but nobody showed up. But they knew it was a good idea, and then Patrick went to O'Reilly Velocity and said, hey, I think we should do a conference on this in Europe, and O'Reilly's like, go do it yourself. And he basically created this conference called DevOps Days, coined the name from DevOps Days. And then it was in Ghent, and I actually had the opportunity to go there. I was working for Canonical at the time with their cloud effort, early cloud efforts, and so I had the opportunity to go there as an evangelist. And it was amazing. In fact, next month we're having our 5th year anniversary. It's going to be a big event. It's a big deal. But to follow the Patrick thread, I was at that Ghent. I came back. I was doing a podcast with Damon. We were like talking about how do we bring this. This has to happen again, and this happens to happen in the U.S. And so me and Damon kind of cooked up the how do we get a DevOps Day conference in the U.S. There was other people that helped, but me and Damon kind of drove it. And so if you say what is my role in DevOps, I've been an evangelist. I've been a believer of it. I speak about it. My probably biggest contribution was that we started the first DevOps Days in the U.S. In 2010, right? Yeah, 2010. And it was a huge success. 300 people showed up. So that's kind of one thread. Along those lines, there was John Allspar, who is also thought of as another real leader in the DevOps movement. He worked for Flickr at the time. And I think it was in 2008, he gave a presentation called 10 deploys to production a day or whatever. And the whole room was like, kind of like, oh my God, the idea of actually doing 10 production deploys a day? And it really freaked a lot of people. I always joked there were people like throwing up in the back of the room, like, this can't happen, my God, the world is ending, I mean, as we've heard stories now of Amazon doing like 1,000 deploys in an hour, right? And that's not a litmus test for DevOps. So it's an idea that creates a flow mentality, iterative processing, all these things. And so John really started this whole thread, and he was he was a big guy in velocity. He was an author for O'Reilly. He was the author of a book called Web Operations, which actually is a really good book if you want to understand the mindset of what everybody was thinking in web operations around 2010-ish. And there's some great chapters. In fact, Eric Ries wrote a chapter, Patrick Dubois wrote a chapter, Andrew Schaefer wrote a chapter, John, Jesse Robbins, who ran all infrastructure for Amazon, was there. So you've got kind of the John Allspaw thread, which becomes the O'Reilly velocity thread. And then Jez Humble, who was supposed to be here, and because of his absence, I'm here. So I apologize to you all for not getting to see Jez. But Jez, what's funny, I used to do this kind of history of DevOps, and after I'd already published an article, I called it Convergence of DevOps, I left out this really interesting thing that in 2006, Jez Humble at ThoughtWorks and a gentleman called Chris Reed and Dan North wrote this article about its continuous flow, and they presented it, they had a white paper, and they did it at Agile. And so they were already talking about this flow, this kind of, this new way of doing SDLC, and so I think they deserve a lot of credit because ThoughtWorks as a consulting company has done a lot to promote the DevOps story. To go a little deeper, how many people have read 4 Steps to Epiphany? Has anybody even heard of it? Yeah. So how many people have heard Eric Ries, Lean Startup? Okay, I was hoping to be more. But yeah, so a lot of people, like Eric Ries was a student of Stephen Gary Blank. The difference between Stephen Gary Blank's 4 Steps to Epiphany and Eric Ries was that Eric Ries actually did a startup where he tried to implement a lot of the ideas. These were things like minimal viable product, customer discovery, all those things. And Eric Ries has been very famous because he started out with a blog talking about a startup where he implemented, and again, it was this flow idea of iterative process, right? Instead of sequential waterfall, and not just for software delivery, but for software delivery and operational delivery, right? And we even as software developers got agile and they were moving fast and working very iterative, the ops people were still in a waterfall mode. So there would be this handoff of these huge artifacts that were like backing up, where ops people would be like, well, we can get that one in November, we can do that one in January, and there was this extreme pressure for operations to deliver faster. And to give Eric Ries credit, if you read Lean Startup, it's a good model and a book of how startups, and actually Jez Humble now is about to publish an enterprise, Lean Enterprise, right, which he's taken that model one step forward. But Stephen Gary Black holds the kind of what I think is the beginning point of that thread. And then how many people have heard of Chef and Puppet? Of course. Okay, good. Now I probably would have left if nobody raised their hand. I'm out of here. This is not going to work. All right. So if you go back 20 years ago, there was a gentleman called Mark Burgess who wrote something called CF Engine, who basically implemented all the core concepts of Chef and Puppet. Item potency, convergence, all these things, right? And you can read his early papers. The problem was he was an academician, and Mark's a good friend of mine. He was an academician, and he didn't give, my first curse word, he didn't give a shit about usability. A lot of people started adopting this, like Amazons and even early days Facebooks were implementing his product because Chef and Puppet didn't exist really yet. Luke Canese of Puppet Labs was a power user of CF Engine, hated the user interface, this is a really short version, and he decided to write his own version of CF Engine, implementing all those core concepts that Mark Burgess did. Became reasonably successful, and even today very successful from a startup pace. And Adam Jacob, who I worked for at Opscode, he basically was a frustrated Puppet user, more about not just the interface, but scale and order and cloud infrastructure drove him to have his kind of breaking off of why I have to write. But the lineage is absolutely clear. In fact, I learned the products in reverse order, and I kept like thinking, oh, Adam Jacobs a genius. He thought of this and this. And then I learned Puppet, like, oh, Luke Canese did that. And then I learned CF Engine, and I realized Mark Burgess actually kind of created all these ideas. So there's that thread. And then finally, last but not least, most people know me, hate the fact that I always have to use Deming in every conversation. I'm a big fan of a gentleman called Edward Deming. And I'll give you the shortest version I possibly can, but this man is so influential on DevOps, it's unbelievable. So short version is, Deming was a physicist who basically got into kind of management ideas, fell in love with the idea of statistics, was actually the first one to implement statistics in the Bureau of Labor Statistics in census analysis. Still used today. Some of his management and quality techniques were used during World War II, where he was credited for winning the war for some of his techniques. After the war, this is where it gets interesting, he gets sent over to Japan to rebuild Japan, right? And he institutes his ideas. And in 1950, at a summit, he tells they have 80% of the wealth of Japan in this one room, and he tells this room, if you implement my ideas in 5 years, this country will be successful. In 5 years, almost to the date, they are successful. And guess what, folks? Deming is the Shakespeare of Toyota Production Systems, Lean. Follow that thread. Lean came over here, with the guys like the Lean Thinking Machine, Lean IT, all that stuff, right? And Lean is a cornerstone of DevOps. So, in other words, Deming is the Shakespeare of DevOps. And so these are the people that you can blame. Unfortunately, you can punch every one of those in the nose except Edward Deming. He's not alive anymore. So that's kind of where, DevOps is about collaboration, breaking down walls. Whatever works, works. There is no, that's DevOps wrong. And when you hear that, the person who's saying is wrong. So the more interesting thing to me right now is this idea of a DevOps, and I think you'll get more from David and David and gang later about what's going to happen. David and Damon, kind of mental black there, more about DevOps, what it is, and all that stuff. But now I'm going to talk about kind of what I think we need to do in DevOps, and I think this is a part where it may or may not relate to what people in this room are doing or thinking about. So there's always these marketing terms. Cloud is a marketing term. DevOps is now becoming a marketing term. Interesting enough, DevOps started out not as a marketing term and has resisted that, but now it is co-op. It's been co-opted by all the vendors, right? But SDDC is a marketing-driven term. So is converged infrastructure. And so converged infrastructure is about basically network, storage, and compute given to you, right? And so that was all the rage a couple of years ago where vendors were converged infrastructure, and we've got your converged infrastructure. In fact, UCS from Cisco is a good example. VSC, the VCE stuff, the collaboration, that stuff, and there's tons of vendors, right? Now the problem is that these were first order, this is like a first order abstraction of these three concepts together, right? Because they were all coupled to hardware, right? So a converged infrastructure implied that I get this box and I got the network and the storage and it's all great, and that's probably awesome. And so VMware, I think, would get credit for creating this buzzword around SDDC. I'm more interested in the opportunities and the possibilities. So to me, what SDDC, Software Defined Data Center, means is taking a converged infrastructure idea, stay with me or leave, that is taking this converged infrastructure to a second order abstraction concept. So if we think about the components here that are defined under Software Defined Data Center, we have, again, compute, storage, and network. Compute is easy. First order abstraction of compute is basically taking a physical machine and making it look like multiple machines, right? 101, virtualization, easy. Storage, a little easier. First order abstraction for storage is taking a physical a storage device, carving it up to look multi-tenant. You got network virtualization. Networking, interesting enough, first order abstraction is this thing called a VLAN. Taking a network device, making it multi-tenant, looking like multiple networks within one box. What are the second order abstractions in all three of these? The second order abstraction is what we loosely call cloud for compute. Something like OpenStack, hate it or love it, is a second order abstraction for compute. Because now you're decoupling or disaggregating the request of the requester from the hardware. Like now, the concept of cloud is we have hypervisors on hypervisors or controllers on hypervisors that dole out, and now the whole idea of somebody requesting compute is free or disaggregated from the actual allocation of that. Storage, what we see there is things like Ceph and cluster and object storage, S3. I think those are clear indications of second order abstraction of storage. Object storage is a great example. There are good other examples, but here again, I need a blob of storage somewhere. And nobody administratively, other than making sure the object store cluster is working, has to go and physically configure anything for a particular place of where that object's going to get allocated. And the place that I've been really excited about in the last year has been the software-defined network space, which again, I think is a second-order abstraction of the VLAN concept. You know, VLAN, I physically have to go to a network device and put in VLAN here and put a VLAN A, VLAN B, and say, okay, these are now going to be this logical network, but very first order. When you start talking about like software-defined networking and things like overlays, and probably the most popular overlay now is VXLAN, right, is this idea that I've completely decoupled the virtual network from the first order abstraction. It is truly a second order abstraction. So when the keynote speaker, and I forget his name because I'm not part of this, and even if you told me, I'd forget it again, but he would say there are no perimeters. I would say the perimeters are quantum. They come and go, they're virtual, they exist, they go away, they're kind of hard to trace. But that is what SDN is as a possibility bringing to us, is that we can do these things called overlays and say, you know what, I know you got switches, I know you got Arista, I know you got Cisco, you got all this crap, but all I'm going to say is there's a virtual instance here, and a virtual instance here, and here is the network that they consist of, and nobody has to update any physical hardware devices to do that. Right? And by the way, if system A needs to move over here, that's fine, because the virtual perimeter, and then sometimes they just go away and come back 3 hours later. So to me then, the DevOps of everything is the opportunity here is that we've been myopic on compute. So like the problem with DevOps today is 99%, well, I'll be fair, 95% of the conversation about DevOps today is about compute. You know, if you think about Chef and Puppet and now Ansible, they're all about perimeters. If you go see any DevOps Day conference, you'll see most of the discussion is about provisioning, configuration on a post OS or virtual instance. Sometimes discussions about storage, very little about network. Although, interesting enough, you know, I actually asked David, will I offend anybody if I don't add the fourth tier here, which would be security? And in general, I think the common, you know, SDDC discussion or converged infrastructure is that security falls under compute in one way and it falls under network in another way. So SDN, how do you get firewalls from an SDN discussion? You put it in the data plane of an SDN. And I'll go through software-defined network in a minute. But the point is, there are great opportunities to step back in DevOps and think about the global picture. James Wickett, and you know, I'm sure a lot of the people involved in this, has done a great job of being an evangelist for things like Rugged and his Gauntlet project, right, and things like that for security. So again, I want everybody to start thinking about what is this DevOps thing. If I'm buying into it, first off, let's start beating the shit out of the people who talk about compute all the time and tell them to stop doing that, particularly if it's your data center. If all the oxygen in your data center is about compute and DevOps and compute, like, and you're a network person or a security person, like, whoa, we need to think about this globally. Like, we need to think about what are the primitives across the board. There's a guy called Derek Carlson who actually was he was one of the architects at TIBCO, and then he went on to create Cloud Foundry, and now he's got his own startup that's been in stealth mode for like 3,000 years. But the point is, he gave a presentation about 3 or 4 months ago where he talked about this idea that, you know, what we should be thinking about now as an industry is this idea that there's this packet or metadata, you know, that says, I'm an application, this is what I need. I need this amount of vCPU, I need this amount of vMemory, I want my kind of network perimeter, virtual and ephemeral, or even quantum if you want, to look like this, right? And so I'm going to specify these things, and now I want to turn that off to some implementation that takes that interface definition and equally distributes those for the application. Again, this is far off stuff, but we're scratching in a lot of different places, and we're way too far in compute, not way less in network and storage, and certainly, and again, I think security is in a really good place to fill the gap really well in this kind of SDDC model. Am I full of shit? Make sense? What? Couple of thumbs, couple of nothings. So how many people are familiar with the concept of software-defined networking? This is the way I become a real jerk. How many people would keep their hand up if I asked them to come up there and explain it to the rest of the audience? We got one. All right. We'll see. Well, then you can tell me if I've done a good job or not. I won't make you come up here. So this is, and there's a lot of views on it, software-defined network. There's also, there's some debate on how it should be, and you could obviously see a debate between Cisco and VMware, but that's a presentation all by itself. But in general, there was this gentleman called Martin Casado. And again, just like earlier, I put first-order names in the list. That doesn't mean they're the only person who did this whole job by themselves. It's just a kind of an anchor for where to get started on the discussion. But this guy, Martin Casado, worked at Stanford, did his PhD in something called OpenFlow, which basically, in general, is credited to be the definition of SDN. He formed this company called Nicira. It got acquired by VMware for $1.2 billion. You don't work for Nicira, do you? Good, okay. Basically, no production customers, really no revenue, $1.2 billion, and everybody's scratching their head and like, what is this SDN thing anyway? But I think there was some magic there, and I still believe that SDN is pretty awesome, despite all the marketing bull crap and all that. So what SDN in principle is, if you look at network devices, you know, switch, route, but I'll just call them switches for now, because switches and routers look pretty similar these days. They basically have 3 planes. In the classic legacy implementation of network devices, you had 3 planes on each device. You had a management plane, control plane, and data plane. Data plane, simply pack it in, pack it out, wire speed. It's the brains of how data moves from where, and how it gets to the next place, and how it gets to the next place. It's basically the internet, right? The control plane, more interestingly, is the brains, the distributed brains at a slower speed that populates the data planes to make those decisions. Those decisions that get generated by the control plane have historically been created by router protocols. BGP, OSPF, those things. And as brilliant as they are in terms of distributed computing, and I always say that in order to be able to build an abstraction of one of them, you had to have been born in 1940 as a computer scientist. The problem was they work brilliantly, they run the internet. In fact, sometimes they break the internet, like didn't we run out of TCAS tables recently? Which, but the point is, the brilliance behind the people who have written those things is basically why the internet and everything is so successful. The problem was they were incredibly hard to abstract. Right? You really, and so in a lot of ways, it was almost like this magic. I basically said I got BGP in this route, I got this BGP in this switch, and you magically distribute and make things happen. And most of the times, things happen the way we wanted them to happen. And when he didn't, it was hell. And what Martin Casado suggested was that I'm going to go ahead, I'm going to take that control plane out of the device, I'm going to put it up in a place, kind of a distributed store, and make it more malleable or more abstractable for normal people that weren't born in 1940 and understood like intensely complex mathematical computer science algorithms, right? And because all he wants to do then is put something, and this is a simplistic model, it's a lot more complex than it, is build a matching table for pack it in, pack it out. And that gets distributed down the control planes. And so the protocol, not the only protocol, but one of the more popular protocols of building kind of a policy-driven match table that actually then distributes down to data planes was OpenFlow. Again, not the only one. I think Chris Hoff almost killed me one day because somebody suggested I said it was the only one in a presentation, so I go out of my way every time to make sure I say that 3 times. But anyway, again, this is a lot more complex in implementation. Companies like VMware's NSX have done a real good job of making humans put policy that this gets translated into, that then gets distributed to do really cool things. And I'll tell you about the cool things here in a minute. Open Daylight is a really interesting open source project following the OpenStack kind of history or flow. And then there's companies called NewEdge and PlumGrid, and there's lots of people who are doing this reasonably well in the enterprise. But here's where it gets interesting. So in router protocols, it was kind of easy to say, I want to make sure packet A, when it comes in here, goes to that port to go out, so hopefully to get to the next hop, and then somehow get, when I whack ender on guitars.com, I somehow get to the right place, right? The problem was the logic in there to do really cool things, like maybe start consolidating firewall rules and actually doing some of the firewall definitions in the data plane, were going to be really difficult to rewrite BGP and OSPF. When you put a very abstract policy level on this, and so again, whether this flies with a classic network person or not mine to argue, debate. But I will tell you right now, VMware is going into large corporations and basically selling this idea of consolidation of IP table sprawl, firewall sprawl, to move it into, and in fact, VMware calls it the Goldilocks zone. You might want to take a look at this idea of the Goldilocks zone as the hypervisor being the perfect place to actually implement. But it doesn't stop there, right? So if you buy into the fact that not only can make arbitrary decisions of pack it in based on data I see, but more complex decisions about I can actually start implementing firewall rules in this data plane. I actually can start doing actually load balancing as a service. It's unlimited to what I can do from a policy perspective to start changing the flow of data based on packet movement. So and that is, folks, why people are very excited about SDN. It is also why Nicira got bought for $1.2 million. On the open source side of this story, the most interesting story is Open vSwitch. So this is the virtual switch data plane, basically. This is where the actual flow tables live. So it's not the physical. And what you'll find is this is kind of lingua franca in non-ESX based cloud implementations as the virtual switch. So, and just to go over the overlay, the virtual network, I talked about VXLAN a little bit earlier. So VXLAN is now very popular on these virtual second-order abstractions and what people are doing to build kind of virtual networking. So in other words, I don't really need to worry about, like from the hypervisor, I don't need to worry about the actual physical connection, like what switch is on, and then go in and define the actual hardwired definitions on that switch to define its relationship with the virtual. So if you take the lower left-hand corner virtual machine and the upper right-hand corner machine, I can actually, by policy, from a tool that is SDN driven, that population control plane pushes it down the data plane, can build that logical construct so that the instances can get to each other, where I don't have to update physical devices, configurations, right? There are some other popular overlay protocols. So I mean, what else is driving this software-defined everything? We've got this disaggregation of hardware and software. So there's things like called bare metal switches. Cumulus Networks, which now actually just sells you the network OS, and you go out and get your own hardware. It's very disruptive. Now, Arista kind of started this. They still sell you the hardware, but they're mostly a software company. And they're very malleable. These are operating systems. Arista is basically CentOS. Cumulus is a Debian distribution. You can bash into the device. No longer do you have to go in and run expect scripts. You can actually go in fact, a lot of these are Python driven, so they're very abstractable from a network perspective. So think about all the security things that go into a network config that you guys may or may not be dealing with every day. Now you can do things, now you can take a look at Chef and Puppet and think an Ansible or blah, 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 as many as you want to go down the list. You can start thinking about how can I actually move from a world. I totally disagree with the keynote speaker. I think SDLCC for everything is the right way to do. I think it is a software world. I think Andreessen Horowitz is absolutely correct that it is that the software is eating the world. I agree with the keynote speaker that tough crap, you better learn how to deal with software. And so that means software-defined everything means everything should somehow probably start in a source repository. Probably Git is the greatest answer and gift to us over the last 25 years. Because it forces us to collaborate on how we work. And so now if everything we do, from network config, from the stuff that James Wickett's working on with Gauntlet, from the stuff that goes into network configs, to the stuff that goes into virtual networks, are all starting out as source repository stuff. And by the way, when we change it, we have a natural collaboration collision because of something called a pull request that forces us to collaborate. And by the way, we should drive that to an integration process. So in the network world, there are people actually storing network configs in Git and GitHub that on a pull request and automatic change going through Jenkins, and in Jenkins running things like either Ginger or ERB templating to fill in the blanks and go out, pull JSON data to populate it, and in some cases running Cucumber. I'm trying to get James to add to Gauntlet some of these network tests, right? So that then you can actually start running what-if questions on site. And by the way, most of these new vendors like Cumulus and Arista and even Cisco now have really cool virtual implementations, so you can actually run a virtual network that is a full leaf-spline structure, so that by the time it gets there, you can do some type of behavior-driven test. And so everything we do should probably be stored and kept in that manner. I'm probably getting close to the end of the time. So again, a software-defined everything, the DevOps of everything. If you're buying into this, what I think the software flow should look like, I think if we accept that software is eating the world, then we should start thinking about abstractions for most of the things we do and not hardwiring config definitions. I mean, that's what Chef and Puppet were about in CF Engine. It was like, back in the day, somebody went into a config definition in the production system and forgot to put a comma in a certain place and brought the system down. And the idea was, there's no guarantee that you build an abstraction to do that. It won't happen. But it's safer. It can be tested. Let's learn from what our software brethren have done, right? So I think the opportunities here, there's some other ideas I think we need to think about. Like I said, I want people to rethink declarative, not just compute. It should be network storage, it should be security. Again, security's done pretty far there. But here's the core of any DevOps discussion is, me and Damon are credited for coining this phrase called CAMS, culture automation. It's a loose, we actually did it on a podcast when we were thinking out loud, and it actually turned into something, and we didn't actually expect it to become a loose taxonomy for DevOps, but it kind of is. So we call it CAMS, culture, automation, measurement, and sharing. And what we say is, if you don't get the culture right, and nothing's going to work. And so if you watch any of the discussions about DevOps and all the things that the people who fail and the people who win, the people who win get this culture right, and they don't ignore the culture. And I've done many presentations on culture. Damon has done many presentations on culture. If you just go to any of the DevOps Days videos, you'll find incredible information about how to deal with culture. If you get that right, you kind of have brilliant fun, because you get to automate, you get to abstract, you get to, in your job, I always used to tell people, it's called the 80-20 flop, right? If in your job, 80% of your day is kind of muck and just stuff that just, God darn it, and 20% of your time is like, hey, you did a great job, or you really feel like you're moving the needle in your organization. I will tell you that the sell I've been selling for 10 years in DevOps is about flipping that. And that most of the people who I know who have been adopted these concepts now will tell you that 80% of their day is about moving the needle, and 20% of the day is about muck and just junk. And how do you do that? It's repeatability, it's just all those things. So some quickly, like, how do you, in an SDC world, how do you get people thinking the same way? Some of the tools that we've used in the software sysadmin, I'll just generally call it compute. Something called value stream mapping work really well for just kind of software delivery in a full DevOps or operations driven. I've been recently using this model for network config definitions. How do you make a network change? How does it go through the flow? Infrastructure as code, I think works. It's a great concept. It should include other things other than just compute and OS operating systems and applications. Continuous delivery is a reality. I think I've talked about that. The flow, Jez Humble has a great book on continuous delivery. I think Kanban is a great operational tool, even if you're in network, security, compute, any part of data center, any kind of IT operations. Kanban is an incredible agile tool. One of the things we've done very well in DevOps, so how do you get DevOps in security? Well, how do we get DevOps in original compute? We basically use this one tool of many, this idea of embedded engineer. We took an ops person, we actually physically moved them into a development team. And that person spent a year in that team and infused ideas. And oh, by the way, wait. When you guys go to create directories here, if you just went a little different here, it would make life so easy over there. Right? So why not, if people are not thinking about that in security, why not? Maybe take an ops person, put them in security. Put a security person in ops. Put a security person in dev team. I'll tell you what, the Facebooks and the Googles and all that, they got these teams called SRE teams. Like they're watching over stuff. I mean, I know you know most of this, but the point is they know this. They've known this for 4 or 5 years. Google, Facebook, Twitter. It's the way they operate. Peering, I do think everything should be in Git. Sorry. Kill me. Put everything in Git. A pull request is a peering opportunity. Right? Hey, somebody's got to review this peer request. I think people just sitting down and peering. Hey, Joe, this is common in software delivery. I'm going to be working on this project here. Is there any chance I can get you to sit down with 3 hours? Yeah, that's great. Now, what does that mean? Enterprise has got to have buffer time. Right? So the whole theory of constraints, Gene Kim's very popular in this community. The Phoenix project is a rewrite of a book called The Goal. Elliot Carrot wrote The Goal. The goal is, at core concept, is something called theory of constraints. Core concept theory of constraints is actually making sure you put buffers in the things you do. So when your boss says, ooh, yeah, Susie going to work for Bill on a peering project, that's going to kill everything. Your boss is clueless. But you need to have those buffers. I've got 5 minutes. I think hack days. So again, and I'm guilty of this. I used to run a lot of hack days that really were only about compute. I go to a DevOps days and we run a hack day, and all we're doing is like a bunch of compute stuff. I'm using compute generally for systems administration, data center, compute. But like, why aren't we having hack days where we have the security folk, the network folk, the marketing people, all in the same room, and let's try to solve big problems. You know Cassandra? How many people heard of Cassandra? Quite a few, right? Fair enough. Like, it was developed in a hack day at Facebook, and Facebook never actually wound up using it. And how many people heard of Netflix? Netflix core architecture is built on, if you watch a movie, thank those people at the Facebook hackathon who just decided to create this different type of data store, because you wouldn't be getting your videos properly if it wasn't for Cassandra. Whatever. Have fun. Hey, if I tell this to network people, your network people are on the 6th floor and their cubicles have coffee stains and it's just mucky and it just kind of stinks. Like, let's just reroute them to the 14th floor, put video games, Nerf pistols. Like this stuff should be fun, because go visit a startup. I was at Puppet Labs 2 weeks ago, and I've watched them go through 4 offices now, and it was fun. You walked in the door and everything about that place was fun. Ping pong tables, beer taps. And most startups are around like this. But there was a cultural buzz, just walking in the door. And I know those guys. I know Luke when he was a one-person company. And even I got a little, like a little, like it felt good in my heart to feel that. Anyway, I'm basically kind of out of time. I think abstraction, I think polyglot, people learning multiple languages in whatever field you're at, the keynotes basically expressed that. I totally agree. I think integration tested, behavior-driven, unit testing, these should be in any type of data center or IT infrastructure discussion. In summary, there's a lot of software opportunity. Embrace the software. Embrace the concept of software-defined everything. Wink at VMware when they say SDDC. Say, I get it. I know what I need to do with that. I know software-defined network. And DevOps Cafe, me and Damon have a fun time interviewing people. Just about all subjects DevOps. And thank you very much for hearing me this morning.